Hello everyone, welcome to Mathematics Method Unit 1. This video will focus on 6F, the graphs of the factorized cubic function, okay? So the learning intention of this video is to sketch factorized cubic function, okay? I know the last video on 6E, we learned how to sketch the graph of cubic function with y equal to a times x minus h to the power of 3 plus k, that type of form. But this one, we're learning to sketch the factorized cubic function, okay? Success criteria. First, I know the steps to draw the factorized cubic function, okay? So now later on, we're going to show you what is the step to draw the factorized cubic function. And the second one is I know how the repeat factor will affect the graph. And again, later I'm going to talk about what does repeated factor mean. Okay, so now here I have written all the steps to draw the factorized cubic, okay? Now, first of all, let's have a look by example 24 on your booklet, example 24. So we are asking you to sketch graph of y equal to x minus 1, x plus 2 times x plus 1. All right, so you see here, because all about this video we're talking about to sketch the graph of factorized cubic function. And over here you see here it's bracket. They are all already factorized in the bracket form. So if you have a look at my left hand side, step 1, factorize the polynomial in the bracket form, okay? So i.e. therefore it should be look like something y equal to a times x minus alpha times x minus beta times x minus gamma. And your form is already written as the factorized bracket form. So you don't need to do the factorize in this question. So now we can move on to the step 2. Find all the x-intercepts by let y equal to 0 or p of x equal to 0, okay? Depends on the equation. So in this example, we have y. So we let y equal to 0 to find x-intercepts, okay? So let's do that. So we're up to step 2 now. So we're gonna let y equal to 0 to find x-intercept, because we know to find x-intercept, let y equal to 0, okay? So therefore 0 is equal to x minus 1 times x plus 2 times x plus 1. Then here is a straight bracket. By law of factor, 3 of this bracket times together is equal to 0. So therefore x minus 1 could be equal to 0, x plus 2 could be equal to 0, or x plus 1 equal to 0. Okay, so then if you solve it out, the first one, x is equal to 1, x is equal to negative 2, x is equal to negative 1. All right, so now these 3 are my x-intercept. So now I'm about to draw the x-intercept. So I have 1, 2, 3. Okay, so 1 and negative 2, negative 1, negative 2, and I also have negative 1. Okay, so here are my 3 x-intercept. So I finished the step 2. Now step 3, check the value of a. Okay, check the value of a over here of your factorized bracket form. Okay, so now if your a larger than 0, you start drawing your wave from the top right. Okay, so what does it mean? Okay, over here you see, here is my equation. Let me use a different color. Here is my equation, which is the cubic function. All right, so then your a is over here. A is actually equal to 1. Okay, so because a equal to 1 larger than 0, so therefore you need to draw the graph from, or the wave from top right. Okay, so here is my top right. Here is my top right. And then, so we're going to start to draw the graph. So here we start. And now here, the first one is here is my x-intercept. Okay, we already calculated. So we know the x-intercept with our graph definitely across there. Okay, so then I'm going to draw from the top right. So top right, we're drawing from top right. And then we across this. And then because here is my second point, so I definitely need to come back to across the second intercept, x-intercept, and then the next intercept is over here. So since I across there, so I have to do another turning to across there. Okay, so roughly your graph look like that. Okay, because your question said you do not need to give the coordinate of the turning point. Okay, so we know the turning point, we have some turning point here, we have some turning point over here or somewhere else. It doesn't necessarily on the y-axis. Okay, so we don't need to draw that. So therefore, roughly your graph has been already so your graph, this is it. Okay, now let's do one more. Your example 25. Example 25. So we ask you to sketch y equal to x to the power of 3 plus 2x to the power of 2 minus 5x minus 6. Okay, so you see here you have this cubic function, the polynomial. However, it is not factorized bracket form like your example 24. You all have the bracket factorized bracket form. This one you don't have it. So then you have to use what I have learned before to factorize your polynomials. Okay, so now to factorize it, remember what we have to use our factor theory. Okay, so now here is my constant. Okay, here is my constant. So therefore constant. So we need to find all the factor of 6. So factor of 6. We have plus minus 1, plus minus 2, plus minus 3, plus minus 6. Okay, so you're gonna try all of this factor to say which one you substitute back to your cubic function to make it 0. Okay, and then because that is our factor theory. Okay, so I'm gonna try 1 to see if I can make it 0. So alright, so first of all I need to write let p of x is equal to x to the power x cubed plus 2x squared minus 5x minus 6. And then therefore I can write that p, when I substitute 1, okay, I'll get 1 plus 2, 1 squared plus 2 times 1 squared minus 5 times 1 minus 6. I have 1 plus 2 minus 5 minus 6, definitely not equal to 0. Okay, so this 1 doesn't work, so let's try negative 1. Okay, negative 1 to the cube plus 2 times negative 1 square minus 5 times negative 1 minus 6. Okay, so that's negative 1 plus 2 minus plus 5 minus 6. Okay, let me double check. Negative 1 plus 2 plus 5 minus 6. Okay, so this is actually equal to 0. So therefore p of minus 1 equal to 0. So by factor theory, x, because alpha is equal to negative 1, so therefore x plus 1 is a factor. Okay, so now and then we need to do the division, long division. Okay, because x plus 1 is the factor. Initially our equation, our cubic polynomial is x cubed plus 2x squared minus 5x minus 6. Okay, so now and we have x plus 1, and then we started to do the non-division. Okay, first two terms. Okay, so and then we're gonna focus first two terms. Okay, the highest power term is x to the x cubed divided by highest power term of your divisor x, you get 2x squared. So you have 2x squared over here. So 2x squared times x give me x cubed divided by x, here is x squared, sorry, x squared. So I'm gonna put that x squared over here. So x squared times x is x cubed. 1 plus 1 plus 1 positive 1 times x squared give me x squared. So then I do subtraction, x cubed minus x cubed, and then 2x squared minus x squared equal to x squared. Okay, so then I have x squared over here, and then bring 1 down, minus 5, and then just continue this process. Eventually you have x squared plus x minus 6. Okay, I need you to finish it by yourself. Alright, so far you should be very familiar with the process for non-division. Alright, so therefore, after you finish the non-division, so therefore, x to the power of 3 plus 2x squared minus 5x minus 6 will be equal to, okay, x plus 1 times x squared plus x minus 6. Okay, so now you see I have converted this form into the factorized bracket form. And however, if you look at this quadratic, this quadratic can be further factorized. Okay, can be further factorized. Eventually you'll have, let me use the different, you have x minus 2 and x plus 3. Okay, so this, you will get this by using the grouping method or other method that you can find. Okay, if I have any problem, okay, again watch my video of straight B, okay, chapter straight B, the quadratic chapter straight B. So therefore now my equation can be rewrite as y equal to x plus 1, x minus 2, x plus 3. So you see here I have converted into the factorized bracket form, which is very similar with the question we got on example 24. And then we're going to follow the next step. So step 2, find all the x-intercept by let y equal to 0. Okay, so then we're going to let y equal to 0. So therefore 0 equal to x plus 1 times x minus 2 times x plus 3. So by law factor, these three brackets times together give me 0. Any of these bracket can be equal to 0. So therefore x plus 1 equal to 0, x minus 2 equal to 0, or x plus 3 equal to 0. Okay, so then I have x is equal to negative 1, x equal to 2, x equal to negative 3. Alright, so I finished step 2. Now I'm going to check the value of a. So over here, you see you have 1 over here. So it is positive. A is larger than 0. Alright, so then we can up to step 3 after we check the value of a. So let's draw all the x-intercept. So x-intercept negative 1. And we also have 1, 2. And so we finish that, and we have negative 3, 1, negative 1, negative 2, negative 3. So these are my three x-intercepts. Alright, and then we know that a, because a is equal to 1 larger than 0, so the graph or the wave starting from top right. Okay, starting from top right. So then we're starting from top right, and we can start to draw the graph. We're gonna cross my x-intercept, the first one, and then we're gonna do the turning so that we can cross the second x-intercept, and then we have to do the turning again to get the third. Now this question, because the question did not say whether you need to draw the y-intercept, so therefore you need to label the y-intercept as well. Okay, so you see here this is y-intercept. So to find y-intercept, let x equal to 0. Okay, so I'm gonna let the x equal to 0. Initially I have my y equal to x plus 1, x minus 2, x plus 3, and then I'm gonna let x equal to 0, so there will be y equal to 0 plus 1 times 0 minus 2 times 0 plus 3. Then you have 1 times negative 2 times 3, then you will have negative 6. Okay, so therefore my graph, so this one is not correct, so then I'll have to redraw my graph. So there's -1, let me use a different color. So -1, -2, -3, -4, -5, -6, -6. Okay, so that I know this is my y-intercept. Okay, so then I'll have to draw the graph, something like that. Okay, so not that part. Okay, because my y-intercept is over here, my y-intercept. All right, so my graph eventually gonna be look like this. Okay, so we're starting from the right. Okay, now let's have a look about example 27. Okay, example 27. Example 27. We are asking you to sketch y equal to x minus 1. Okay, it's negative x minus 1. X squared plus 4x plus 5. All right, so then step 1, factorize the polynomial into bracket form. So you see here bracket, so it's already bracketed form. So now we just need to find, so then we finish step 1, so we need to do step 2. Step 2, find all the x-intercept by so find x-intercept, let y equal to 0. So I'm gonna let y equal to 0. So 0 is equal to negative x minus 1 times x squared plus 4x plus 5. All right. Now, again, by using null factor, we have two bracket times together. Both of them times together equal to 0. So either x minus 1 equal to 0 or x squared minus 4x plus 5 equal to 0. All right. So therefore, to solve out this one, x is equal to 1. Now, for this part, quadratic, then how do we solve this out? Okay, if you try to use, let's say we have the quadratic formula, okay? So we know quadratic formula, x is equal to, so 2a on the bottom, negative b, okay, so quadratic formula, let me write over here. So that will have to be -2a -2. All right. So now, let's see here. This is my discriminant. Okay. So now my a is equal to 1, b is equal to -4, c is equal to 5. All right. So delta is equal to b squared minus 4ac. Okay, so if we substitute, b squared is -4 squared minus 4 times a times 5. So you have 16 minus 20 equal to -4, smaller than 0. Okay, so you have a discriminant that's smaller than 0. That means you will never solve out this equation. Okay, because square root -4 doesn't exist, so you can't solve out. So there's no solution for this one. So therefore, x equal to 1 is the only x-intercept you have. This is the only x-intercept you have. All right. So now we have finished step 2. We find all the x-intercept, which in this case, the x-intercept is only the 1, x equal to 1. Okay, so now we're up to step 3. Okay, so we before we do step 3, let's just plot that all the graph over here. So the only x-intercept is x equal to 1, so I put over here x equal to 1. All right, so now step 3 is check the a of your factorized bracket form. Okay, so now let me rewrite that. My form is negative x minus 1 and times x squared plus 4x plus 5. Okay, so then you see that is my a. Okay, so a is actually equal to -1, smaller than 0. So check your step 3 on the left hand side. When a is smaller than 0, we're starting the graph from bottom right. Okay, so we're starting from the bottom right. And then we're gonna cross that x equal to 1 intercept, and alright, and then we know it's gonna extend, and then there will be a y-intercept. Okay, so then you need to calculate to find y-intercept, let x equal to 0. So therefore y will be equal to -1 times 0 minus 1 times 0 squared plus 4 times 0 plus 5, and then that will be equal to 5. Okay, so then we'll have 1 2 3 4 5, and then if I can extend, so then I know that will be across that. And then for the rest of the part, that there's no way that we can draw by hand because we don't know the x-intercept for the therefore if you use CAS, okay, then your CAS gonna tell you your graph will be look like something. Okay, so you're gonna be look like so probably we'll pass that the y-intercept over here, and then you will need to so it could continue, or so you can decrease and then increase again, and then over here should be roughly -2. Okay, so the green part is you need the CAS calculator to help you draw. All right. So far we have finished the first successful criteria. You need to be very familiar with these 3 steps to draw the graph. Now the next one is the next success criteria is repeat factor. You need to know repeated factor leads to turning point. Okay, so now what does repeated factor mean? All right, so the one example can help you. Okay, let's do example 26. Example 26. Then we ask you to sketch the graph. Y equal to x squared minus x minus 1. Okay, again, let's see. We're gonna do the same steps. Okay, so step 1, factorize the polynomial form in a bracket form. So it's a bracket, okay, x squared times the bracket. So it's already factorized bracket form. Okay, so then step 1 finished. And then we do step 2, find all the x-intercept. Okay, so by let y equal to 0. So we're gonna let y equal to 0. So that will be 0 equal to x squared times x minus 1. Okay, so this part times that part equal to 0. So it will be either x squared equal to 0 and x minus 1 equal to 0. So if I solve it out, x minus x equal to 1. This one is because you see it is a square. So that square tell me we actually have two overlapped values. So then x is equal to 0, but I have two repeated factor, right? Because it is square. So that's why when you solve out your equation x equal to 0, you actually have two x equal to 0 that is overlapped. Okay, that is overlapped. Okay, if you don't get ideas, so and let me think about different way to help you to understand. All right. How about this? Okay, so here's some extension for you to understand why this is, because as you probably think this x is equal to 0 is only 1, why we have two solution over here. All right, so now how about let's do this. So if I draw parabola, because we know y equal to x squared is a parabola. So if I have parabola over here, so if I x-intercept, that's my solution. All right, that's my, because the y is equal to y equal to 0, so that's my x-intercept. So if I just continue to move it up, and then it be moved to over here, and then continue to move over here, and then until that turning point only touch that, so that 2 point overlapped. So that's the case when we have one solution. So over here, even though you have x equal to 0, it looks like you only one solution, but it is actually that 2 point that overlapped. So when you have that square, then that tells you you have 2 repeated factor. Okay, so now repeated factor over here on the left side, not on the left hand side, leads to turning point. Okay, what does it mean? Let's continue. Okay, so now you have find all the factor. Okay, you find all the factor as in the solution. Okay, so you find all the x-intercept, x equal to 0. Okay, be aware this is the repeated factor because that's square over here, and then you have x equal to 1. Okay, so now let's draw the graph again. Let's plot all those x-intercept over here. X equal to 0. Okay, so this is my repeated factor, and x equal to 1. All right, again we're gonna do something similar. We're up to step 3 now. Check the a value. Okay, so now my equation is y equal to x squared times x minus 1. Okay, so my a is actually over here in the front, 1. So a is equal to 1 larger than 0. So therefore the graph starts from top right. Okay, so this is my 2 points. So I'm starting from top right. So I'm starting from here. I'm gonna go across my x equal to 1 x-intercept, and here is my next intercept, x equal to 0. So I know I'm gonna come back. Now, because the fact that this is your repeated, factor. Okay, this is a repeated factor, therefore it is a turning point. So technically, if this is not repeated factor, I need to cross it, but it is repeat. So this is my turning point. So that tells me as soon as I reached this repeated factor, I need to do the turning. Okay, so I need to do the turning. So that kind of bend my graph to the other direction. Okay, and then here, so this is my graph over here.